Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The structure shown is 1,1,2-primethylcyclohexane. C1 bears 2 methyl groups, gemdimethyl, and C2 bears 1 methyl group. Moving on to the next step. Identify stereocenters for geometric, CIS trans, isomerism in cyclic compounds. Geometric isomerism in cycloalkanes arises when 2 different ring carbons each bear 2 different substituents, allowing for CIS and trans arrangements relative to the ring plane. Moving on to the next step. C1 has 2 methyl groups attached to it. Because both substituents on C1, the 2 methyls, are identical, C1 is not a stereocenter and cannot give rise to CIS trans isomerism. A carbon bearing 2 identical groups cannot show geometric isomerism. And for the final step, C2 has 1 methyl group and 1 H. However, geometric isomerism requires both ring carbons involved to have 2 different groups. Since C1 already fails this requirement, it has 2 identical methyl groups, there is no CIS trans relationship possible between C1 and C2. Because C1 is a quaternary carbon with 2 identical substituents, to CH3 groups, the molecule cannot exhibit geometric isomerism. There are 0 geometric isomers possible. Why other options fail? B, 2, C, 3, D. 4 all assume stereogenic centers exist, but C1 with 2 identical methyl groups disqualifies any CIS trans isomerism. Therefore, the correct answer is A. Therefore, the correct answer is option A.